Hello everyone, a very warm welcome to the Chem School. I hope you have enjoyed the first lecture on aromatic compounds in which I gave the introduction and I gave few structural molecules for you to by heart. I hope you remember those molecules, and with that particular concept we will proceed with the next one. So today we are going to start with the proper nomenclature of aromatic hydrocarbons. So I hope you enjoy them. Let's start. Okay, so let's start with the topic. So today we are going to talk about substitute aromatic compounds, and the first topic that I am taking for the day is halogen and nitro substitute compounds. Now why I am taking this? Because halogen compounds and nitro compounds are taken as substituent. If they are taken as substituent, remember one thing, the priority will be based on the alphabetical order. So the one who is going to have the lowest alphabetical order will be the highest priority group. What do I mean by that? Let's talk about the first example. You will understand this very clearly. So have a look at this one. If you see, if I do the numbering for this one, it is going to be from 1, 2, 3, 4, or it can be 1, 2, 3 and 4. But now check. You have bromo which is starting from B, while this one is chloro which is starting from C. So the lowest alphabetical order is B. So the numbering will start from here. So 1, 2, 3 and 4. I hope this is clear to all of you. I repeat, lowest alphabet, highest priority. Fine. So let's do the naming for this one. So you can see that 1 and 3 is your bromo. So write down that name. So 1, 3, 2 bromo, therefore dibromo. Right? Then come to chloro. So you have 2, 4 dichloro. And ultimately the ring, the nucleus is of benzene. So you will say it is benzene. I hope this is very clear to all of you, right? So this is your name. Now let's talk about the next one, right? You have nitro which is starting from N, and you have chloro which is starting from C. So chloro is going to be your first priority. So 1, 2, 3 and 4. So the name will be 4 nitro, right? Then 1 chloro benzene. You can also take the orthometa para nomenclature. So with respect to this chloro, nitro is on para position. So you can say it is para nitro chloro benzene. Right? It is understood that if nitro is on para position, chloro is going to be on the first position with respect to this. And this is the name that you have. Right? I hope this is very, very clear to all of you. Have a look at the next one. Now you should know that in the last class I have spoken about that benzene with CH3 is called as toluene. I repeat, benzene with CH3 is going to be toluene. So that is going to be your parent. Your parent is not going to be benzene in this case, right? So let's see. So because toluene is your parent, the first numbering will go to CH3. That is the reason I focused on all the substitute hydrocarbons in the last class, because they are very important, right? So this is 1, 2, 3, 4, 5, 6. Now do the numbering. So 2, then 4, then 6 is nitro. There are 3 nitro. So you will say it is trinitro, and the ring is of toluene. So it is trinitrotoluene, and it is also known as TNT. You might have heard of this. This is an explosive, right? So this kind of compounds are explosive, so they are not very used like regularly. Not a normal student is allowed to make this type of compounds. Fine. Have a look at the next one. Now these are again nitro compounds, so it is 1, 2, 3, 4. You can also start the numbering from below. That is absolutely fine because both are nitro, right? So the compound name will be 1, 4 dinitro benzene, right? And you can also call this as para dinitro benzene. So it is understood that both the nitro are para to each other. So this is how we do the numbering when you talk about aromatic compounds. Now we will take some functional group and try to do the numbering as per the priority. So let's start. So let's talk about the second nomenclature, that is carboxylic acid and its derivative. Fine. Now I have already written the name because those are very simple, but still I'll explain the structures to you and numbering as per IUPAC. Fine. So let's start. Have a look at the first structure. If you remember, in the last class I said you that benzene with COOH is called as benzoic acid. I repeat, benzene with COOH, like benzene ka ring C6H5 is said to be pH, phenyl, and then if you say this COH, then you can call this structure as benzoic acid, right? And today I said you that benzene with CH3 is called as toluene. I have said this in the last class as well. So now if I club this together, that is benzene with CH3 toluene and benzene with COH, benzoic acid. So together they are called as toluic acid. I repeat, together they are called as toluic acid. Now look at the position. Fine. Now if I say that benzene is priority 1 and this is 2, right? So I can write the name in one more form, that is I can say it is 2-methyl benzoic acid, right, based on this. But if I take the other way around, that is if I take CH3 as the first one, priority, it is not the priority, but still if I say benzene with CH3 is toluene, then that becomes the parent and it becomes the priority that way. So 1 and 2, right? So in this case this is toluene and this is acid. So you can say that this is like, as per this, it is 2-toluic acid, and you can also call this as ortho-toluic acid. So all this nomenclature is right. That is the problem with aromatic compound, that you cannot say okay, my answer is correct. There can be multiple answers, so do take care of that. Fine. Now have a look at the next one. Benzene with OCH3 is called as anisole. I repeat, benzene with OCH3 is called as anisole, right? And benzene with COH is called as benzoic acid. If I club them together, it is called as meta-anisic acid. I repeat, it is called as meta-anisic acid. And meta position, if I say, let's say now it is 1, 2 and 3. As per aniline, aniline is going to be parent. See, you have written ani, right? So if I say it is 1, 2, 3, right, then you will say it is 3-anisic acid. Or if you change the numbering, if you take this as 1, 2 and 3, then you have one more name, that is you can say it is 3, this is OCH3, methoxy. So 3-methoxy benzoic acid, benzoic acid. So do take care of all this nomenclature. Have a look at the next one. This is pretty simple. Like if you have benzene with 2 COH together, then it is called as phthalic acid. I repeat, it is called as phthalic acid. So benzene with COH together is called as phthalic acid. Next one. If I take this numbering, so 1, 2, 3, 4, 5 and 6. So you can see that third and fifth have bromo, right? So you have 2 bromo. So the naming is pretty simple. You will say it is 3,5-dibromo and the nucleus is going to be benzoic acid. So 3,5-dibromo benzoic acid. This is again very simple. Have a look at this one. So if it is 1, 2 and 3. So on third position you have nitro. So you can say meta-nitro or you can say it is 3-nitro benzoic acid. The next one. I have taken one example in the previous type. So in this case, if I say this is 1, 2, 3, 4, 5 and 6. You can see that on 2, 4 and 6 you have nitro. And one more thing I want to tell you. See, benzene, carbon is attached to the nitrogen. Therefore, while writing, I have changed this form. Do not write it like this. It means the carbon is connected to the oxygen and that is considered to be a wrong structure. Therefore, you will see in most of the book, they write like this. So that is the right form. Fine. So I hope you have noted this as well. So in this case, if you see the name, it is 2,4,6 trinitro and benzene with COH is benzoic acid. So 2,4,6 trinitro benzoic acid. The next one. Now this structure was like, if I just remove the COH, this is naphthalene, and naphthalene I have also taught you the numbering, right? So if you see, this is 1, 2, 3, 4, 5, 6, 7, 8 or 9 and 10, or this can be 9 and 10. I said you in the last class based on the substituent where it is. Fine. So this is the numbering for naphthalene, right? But if you have a substituent on this, let's say I have COH on the second position, so that becomes 2-naphthoic acid. I repeat, that becomes 2-naphthoic acid. The next one, I hope you can definitely write out the name for this one. Let's do the numbering again. So it is 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10, right? So you have one substituent on 6 positions. So you have bromo, so you will say it is 6 bromo, right? And the second carbon has COH, so 2 naphthoic acid. So I'm very sure that you can also write down the nomenclature for naphthalene. So this was all about carboxylic acid and its derivatives. We spoke about benzoic acid, and now let's talk about its derivatives. So have a look. Now if you have this benzene with COH and I just remove that H and replace it with a metal, so that becomes a salt, right? So here I have taken sodium, so that becomes sodium salt of benzoic acid, or you can directly say it as sodium benzoate. I repeat, you can say it as sodium benzoate, or you can also call it as sodium salt of benzoic acid. Both is correct. Fine. Have a look at the next one. Now if you have benzene with C double bond O Cl, so that is acyl chloride. Fine. So physically you have this benzene, so you will call this as benzoyl chloride. You need to memorize few names in aromatic compound. We cannot help it out. Fine. So let's see. Have a look at the next one. Now this is benzene with like acyl C double bond O Cl group. Fine. So this is benzoyl chloride, but OCH3 is benzene with OCH3 is aniline. So together they are called as para-anisole chloride because they are para to each other. Or you can also, para position is also 4th position, so you can also say it is 4-anisole chloride. Both is correct, right? So para-anisole chloride or 4-anisole chloride. Have a look at the next one. Now benzene with C double bond O NH2 is called as benzamide because it is an amide group, right? So this is benzamide. But now you can see that with respect to this, second position is chloro, so second position is ortho. So you can say it is orthochlorobenzamide, or you can also say it is 2-chlorobenzamide. Both is correct again. The next one, if you see, these are esters. So in case of esters, you remember I said you that you have to first name the group that is attached to this oxygen, right? So have a look. In this case, oxygen is having this CH2, CH2, CH3 group. Now this is in a straight chain, so this is N-propyl. So this is N-propyl, and this group is benzoate as we named it here. And this group is benzoate. So that becomes N-propyl, this part, the one that is attached to the oxygen, right? And this part is your benzoate. So that becomes N-propyl benzoate. The next one, again, now benzene with CH3 is toluene, so that is your parent, right? So that we will write at the end because it is an ester, toluene will become toluate. I repeat, because it is an ester, toluene will become toluate. So this is your toluate. Now the group that is attached to oxygen that you have to write it first. So oxygen ko kya attached hai? You have CH3, so you will say it is methyl. So it is methyl, right? And they are ortho to each other, right? Because they are next to each other. So this is your methyl, and this entire group, this is your toluate. This is toluene, and C double bond O minus is your toluate. So that becomes methyl ortho toluate. I hope this is very clear to all of you. Have a look at the next one. The group that is attached, see on the ring you have nothing else. So you just have this benzoate. So we'll take care of this later. But have a look at the other part. Now this oxygen is attached to this part, right? So with respect to this oxygen, so this is 1, 2, 3 and 4. So you have chloro on 4th position, and 4th position is para. So you will say it is with respect to this para-chloro, and this chloro is having a phenyl attachment to it. So you will say it is para-chlorophenyl, and then this ring is your benzoate. Simple, just break it into pieces. So this becomes para-chlorophenyl benzoate. I hope this is very clear to all of you. Fine. Have a look at the next one. If you remember phthalic acid, right? So from phthalic acid, if I just remove water, if I just do dehydrolysis, H2O, right? Just remove water. So after removing water, this is the structure that you get, right? So whenever you remove any water molecule from something, you say it is an anhydride, right? So because I removed water from phthalic acid, now this becomes phthalic anhydride. So this is true for all of them. For example, acetic acid, if you have two acetic acid and if you remove water, you will say it is acid anhydride. Similarly, if I remove water from phthalic acid, it becomes phthalic anhydride. So this is one more thing that you can remember. The next one, benzene with CN, that is cyanide group, is called as benzonitride. So this is finally the completion of acid derivatives. I don't want to take a lot of structure on one day so that it becomes difficult for you to memorize. So we'll stop here for the day and see you soon.